Alright, alright, here it is. This is our last video for tonight. It is using guidelines to sketch a polynomial graph. So let me pause and see if I can find some graph paper. Okay, so the process is pretty much the same. We describe the end behavior. The end behavior here is, why is this not working? End behavior is, it's odd, so therefore it is down, then up. The y-intercept will be, it goes through the origin actually, because if you plug in h of 0, all these terms become zeros, so it goes through the origin. And finding zeros, now that might take you a little while, so I'm going to pause while I do them, and I'd like you to pause as well and try to figure these out. Remember that you're going to factor out the GCF first, and that's the hint I'll give you on this one. So you have a 0 of multiplicity 3 here, and that you can factor out of x cubed. So your factor x has a degree of 3, which means the factor is actually, or the 0 is 0 if you plug in a 0 there, right? So it's got a multiplicity of 3 there at x equals 0. You got x to the 4th left minus 4x to the, subtracting 3, or yep, 3, and then 7x squared, and then minus 12x, and then plus 12. So since this is a 1 here, using the rational zeros theorem, we know that any factors we have to be factors of the constant term divided by factors of the leading term. Well, this is 1, so we just have to worry about the constant. And let's see, that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12 are the factors of 12. And we're going to try these. Always try one first, and let's see what you get. All right, I'm calling this result here g of x, and then g of 1 will be 1 minus 4 plus 7 minus 12 plus 12. And these guys cancel. 7 plus, let's see, 8 minus 4 is 4. So what I get is g of 1 is 4. Now that's a point I can graph, and I will later, but it shows me that x minus 1 is not a factor. What about g of negative 1? Let me pause again. Now this time I got g of negative 1 is 36. Now I said before that this was a point, and the reason why this one's a point is because if we plug in a 1 here, 1 cubed is still 1, so 1 times this result, which was 4, means h of 1 is 4. However, h of negative 1 is not 36 because negative 1 cubed is negative 1, so negative 1 times 36, that result would be negative 36. So we have those 2 points, and we know that neither one is a factor in the original. I'm going to move on and try 2. 2 we can do by synthetic division. So just got to make sure that all my factors, or all my terms are in decreasing degree, that I'm not missing any. 4, 3, 2, 1, 0. Yes, and then bring that down. So 1, 2 times that, 2, negative 2, negative 4, 3, 6, negative 6, negative 12, 0. Ooh, we found one. And actually just looking at that, I see that it's factorable by grouping the next one, because 1, negative 2, and 3, negative 6, we can basically factor out a 3 out of that. Anyway, so what does this mean? So right now I have this factored down another step. Let me go like this. We have x cubed. Now we pulled out a 2, so times x minus 2 times x to the third minus 2x squared plus 3x minus 6 is the next. Now I said that was factorable by grouping, to show that, I'm going to do that right here. Where's my, I'll take red, group these, group those. Okay, I can factor out a x squared out of those, I get x minus 2. And I can factor out a 3 out of those, and I get x minus 2. So therefore, I get x cubed times x minus 2 times x minus 2 again times x squared plus 3. This is factorable again. It's a sum of squares, which we know factors into x plus square root of 3i times x minus square root of 3i. Or you can call it an irreducible quadratic factor if you'd like. But if you're factoring it completely, that's where it goes. And then you have this x minus 2 has a multiplicity of 2. And that's pretty much it. So let me go to this. Oh, how do I get my arrow back? Fill text. Oh no. Creative pens. I just want my pointer. Select control 1. Okay. So let me, oh, I can't slide this over. I want to. But anyways, this is the result. So now how are we going to graph that? Well, first thing I'm going to do is I'm going to group all these and shrink them and move them down here. And I'm going to go like this. And on here, I want to kind of switch views here and use this to make my graph. It's trying to be neat. There we go. We got an x and a y axis now. All right. The y-intercept I said was 0. So let me make let me make a point at 0. So, and that root has a multiplicity of 3, so we know it's going to have a little chicane there. This is down up, so it comes from the bottom. This x minus 2 means it crosses at positive 2. And it does, oh, it doesn't cross, it bounces off. And then these are complex factors, so something crazy happens. What happens? Not sure. Okay, any other factors in there? No, that's pretty much it. So we don't really have a ton of information here. So what you might want to do is, well, we have 1, 4 we can use. 1, 4 is right there. And so we know it kind of goes like this. And it bounces off. And then what else do we have? We have negative 136. Negative 136 is somewhere way up high. Oh no, that's not right. It's negative 1, negative 36. So it's somewhere way down low. So basically, I wish I had spread this out. Why can't I? Let's spread it out. All right. Instead of skipping by 1, let's skip by 2. So this will still be 0. But now, when we skip by 2, we'll get a little better graph here. Okay, what were the roots? 0. So that's a point there. Positive 2, that's a point. 1 comma 4, 1, 2, 3, 4, that's right there. And it's coming from the bottom because it's down up. So it goes like this. Oh, I totally missed. Comes like this. Hits that. Now I don't know if that's the absolute maximum. So, but I'm not gonna make a big deal out of it if I'm a little inaccurate here. And what happens here, it touches down, it bounces off, and it goes back up. Now, is this an absolutely perfect graph? No, actually I already messed it up once. Do you see the mistake? Look back at my multiplicities. What was the multiplicity of the x minus 2? 2. So I did that right. What was the multiplicity of the x cubed? 3. Of the x, it was 3. So what should happen here? Should it go straight through at 0? No, it should have a little chicane to it. So let's fix that. All right, let me pause. All right, so there we have it. It goes through at 0, multiplicity of 3 gives it a little bend. 1, 4 we figured out was, we don't know that it's a local maximum, but it's okay. And then this point right here is 2. It's got a degree, a multiplicity of 2, so it bounces off. End behavior is down, up. And that's about as good as we can do knowing what we know in this chapter.